Hello everyone, welcome to another video tutorial. In this edition, we would be talking about building an IoT home automation with energy monitoring system. It also has a voice feature using an app that uses Bluetooth communication protocol. We would be designing this app using the MIT App Inventor platform. This app displays the energy as well as the power consumed by showing the voltage and current measured by the project on the app. You can also control the home model using an app button widget, or you can use the Bluetooth feature and just click on the mic that is on the app, say a particular command, and it will do the task. For this project, we have built a small model for the design where we have attached our light bulb, the socket, and of course a fan. Of course, we'll be showing you how to build this project step by step, so stay tuned. As you can see here, we're already controlling the light socket. By just a click of button on the app, and you can also see that by pressing the app, the socket is already on. This is because the app itself uses a server, a Thingspeak server, which we can use to communicate. Next, we'll talk about the components and modules needed. First thing we need in this particular project is the components and the materials. But however, you can get a list of all of this from the link in the description below. I have already prepared a written blog post on this topic, and I have also explained in the blog post the calculations that was carried out before the choices of these materials were made. So all you just have to do is click in the link in the description below to get all of this. I hope that should be able to tell you each of the choices we made, because we did a lot of them and we have already written them down in the blog post. Alright, next is the schematic diagram. For the schematic diagram, you should know that the project design uses a motion sensor, the PIR motion sensor, to put the home model as designed into an auto mode, which turns on the lights and other needed appliances in the home. The project is built with the ESp32 board as shown in this particular schematic diagram. However, the Bluetooth module was connected using a serial communication protocol. So there is a software serial communication protocol which we use to talk to the Bluetooth module, which is the HC04A05 module. We also use 3 relay modules to control the appliances in this particular project as shown here. You can read more of this in the description below. Alright, so that said, let us quickly go to the next step. So we'll talk about the component and assembling of this particular project. Usually, before we couple or assemble the project, we must have soldered the needed parts in the project design. Although this soldering portion of this of this project design was not covered in this particular video. Just try and make sure that it is not other lengthy, or you have to couple the project, you have to solder the project before actually proceeding to the coupling and assembling parts. So after the soldering is done, then you have to jump into this particular stage. First, we'll begin with aligning out each component as they will be placed in the enclosure. For us here, we didn't use a custom print of a 3D model. We didn't print out our casing using a 3D printer. We used our old-fashioned 6x6 inch box for this particular project enclosure. So we used the glue gun. After we must have aligned the projects, we use the glue gun to glue them to the base of the enclosure. And we began with the single channel relay module. After this, we are glued together, and you can see it is already nice the way we placed it. The next thing would be to also glue the other parts or other stages of the component, like where the ESp32 board is being soldered. So after we've glued that, we'll glue the power supply and the current sensor and the voltage sensor for the project design. Alright, so once we are done with the gluing of the components and arranging them in a particular order of our choice, we move on to the cable management for the project design. Since the project itself, we use the GST header and cable to connect all the sensors and the actuators in the project enclosure. We had to use a cable tie to quickly manage the cable in the 6x6 box as seen here. So we neatly tie this cable together just to make sure that they don't end up in the wrong side that are not necessarily needed. So it is also good to know that while you are managing the cable, or while you are doing the cable management of the project design, always ensure that the temperature sensor, which is used to display the temperature of the room or the model room, is actually kept outside. Also, it will be good for you to like, subscribe, and enable the notification button for any of our future videos that you might be interested in. Alright, for this particular project design, we use the Arduino IDE obviously to program the ESp32 board. And as you can see here, this is the code. Don't worry, you can always check the link in the description below for it. You can download it free of charge, nobody's charging you money for it. I've already included the link in the description below. So this is the Arduino code that was used to program the ESp32 for the project design. So we use some couple of variables, we declare some couple of variables to hold our Thingspeak channel, since we use the Thingspeak channel to send the sensor data and then read it up from our app. Then we also send the input buttons IOs to also another Thingspeak channel. So that is the channel declarations we did here. And also since our project design also used a motion sensor and also the temperature sensor, we also declared it here too. So these are some of the important variables that we used. So the rest of the codes are self-explanatory, and I tried to include a comment line to tell you what each of the code lines are actually doing, so you can always download the code free of charge and use it. However, what this particular code and the functions here are trying to do is, we have a function that whose job is to send the codes to the Thingspeak platform. We also have another function whose job is to read from the Thingspeak channel and display it, on the app. But we also have a function that is responsible for the auto mode control of the home model. So basically, the auto home control comes in when the PIR motion sensor detects motion in the house, and automatically it turns on the fan using the temperature of the room. So if the temperature is in between a particular area, what it's going to do, it is going to run that particular fan at a particular within a particular range. So, and all of that, it also turns on the socket. So once you're done, you can just plug in your project to your Arduino and plug it to using your USB ports, and you can then upload your code to the ESp32, and then you can watch the whole project come to life. So you get to see the state of the socket, if it is on or if it is off. You can always press the app and see how it is responding in like real time using the serial monitor. Alright, so let's jump into creating the app using the MIT App Inventor. So basically, the MIT App Inventor was what was used to create this particular app. Well, for those of you that doesn't know how to use the MIT App Inventor, don't worry, you can just click in the link in the description below, or just send a comment and I will drop you the raw file. All you just have to do is upload the app to your MIT App Inventor project and make a minor tweak, like changing the channel ID and some of the Thingspeak read and Thingspeak write channel keys, and you can make the project totally yours. So you don't have to worry about that. Just click in the link in the description below for that. Okay, so you have two sides of the app. You have the design side and you have the block side, and I think you could design for both Android and iOS platform if so chooses, so it makes everything easier to use too. So this is basically how the whole app was designed, and that's just that. Just click in the link in the blog post link below and get the app, or you can just comment or chat either on Telegram or WhatsApp to get the app for yourself. in order to test the project, you need to power on the project. When you power on the project, you can see the voltage, AC voltage and AC current, and the power and the energy measured on the app. Now you need to connect the app to via using your Bluetooth connection. You need to pair the HC05 module in the project design. You also need to connect the app to the Thingspeak server. That means that the Wi-Fi communication, the Wi-Fi needs to be connected to any internet hotspots. So once that is done, you can press the button widget to turn on the fan, and you have to wait to give it a little bit of time because it takes about 10 seconds to get to Thingspeak. So once you press that, you wait, and then you will see that the light is going to come on. Now once the light comes on, you can also go back to the app and check the state of the light bulb. It should say that it is on, as shown here now. Then you can also press that same button again, and it is going to turn off the light bulb. The same thing is also repeated for the socket. The same thing is also repeated for the button of the fan control, and this is for the user control of the project design. So but in the auto mode, once the motion sensor is being sensed, the light automatically comes on and the fan is going to be running at a particular speed based on the temperature of the room. Alright, so that is the socket coming on at will when the user pushes the button on the app. So the project itself works on two modes: the user enable mode and the auto mode, which is where it controls the appliances by itself. And it's not just controlling the appliances, it's also displaying and measuring the energy used by the appliances in the home model. So lastly is the Bluetooth controlled feature, which is where you press this particular mic here and you say a command, and by the time you say a command, it is going to automatically do the command based on what you are telling it to do. So that is how the project works.